In today's lesson, we are going to be learning about nets and drawing for visualizing geometry. So the goal for today is to kind of connect two-dimensional shapes to three-dimensional shapes. Our first term that we're going to learn about is a net. A net is a two-dimensional diagram that we could fold into a three-dimensional figure. Here in example one, we've got an example of a net. So they're saying to take a look at this three-dimensional graham cracker box. And if you were to tear the box along the seams, you could spread it out into a two-dimensional figure, like this one down here, which if we fold it along the seams again, we should be able to construct a three-dimensional box like we started with. So that's kind of the connection between the second dimension and the third dimension. So a net, if we fold it, we should be able to create a three-dimensional object again. This is very helpful if we want to calculate surface area of three-dimensional shapes. We might deconstruct it and turn it into a two-dimensional net that we could then measure. Here in example 2, they're asking what would the net be for the figure at the right. So if we take a look at this, we've got a triangular prism. Let's see, we've got a triangle, and they kind of just elongated it. So while I have a triangle here on the front-facing side, as we move back, these are just rectangles. This shaded side here is a rectangle, and the base is a rectangle. And then the back is going to be another triangle. So I'm really looking at three rectangles with two triangles. So let me start with the rectangles. They're pretty long and narrow. I think I've got something kind of like this. So they tell me the base of the middle is 7. These side lengths are 10. And I know that this has a width of 4. So these are my rectangles. Now I need to draw the two triangles. So I can draw them coming out of the middle like this. These are going to have length 10 and 10, 10 and 10. So this would be my net. Notice how the length 10 lines up with the length 10. That way they should meet at the top. Yeah, if we were to fold this, we should definitely get the figure at the right. So for B, they're asking, is there another possible way for us to draw this? And the answer is yes. Depending on where you try to deconstruct the three-dimensional figure, we can get different nets that will still fold into the same figure. So I'm going to start with my three rectangles again. But instead of having my triangles go off the middle section, I could have the triangles go off, maybe this left rectangle here. This would be 7 and 10, 7 and 10. And this should still fold up to be the same three-dimensional shape, even though the net was different. So I just have to make sure that all of my dimensions do line up, and it does look like they are. So hopefully this gives you a nice understanding that there are multiple nets for each three-dimensional figure. So just because your answer looks different than your neighbor's doesn't mean that anyone has to be wrong in this case. So the next type of drawing that we want to talk about is called an isometric drawing. And an isometric drawing is a corner view of a three-dimensional figure. So this right here, this is an example of an isometric drawing. And then these blocks down here, this is the isometric view. So many times if we're looking at something in the three-dimensional world, which is what we live in, we may want to draw an isometric drawing so that I can see a front view, a right view, and a top view. This gives, even though we're working in 2 dimensions, it gives us a little more perspective of what we're really looking at. So there's a couple different ways you can draw these. If you've got some dot paper, like you see in the example here, this can help. I always find that if you can draw one of the sides, it makes everything easier. So they started with the L here, which kind of corresponds to like this front side of these 3 blocks. I then try to add some depth to the picture so you can see they're adding a total length of 1 diagonally, and that's going to add this depth here. And then in the last step, they just close everything off, so they kind of doing this like step motion here. So this can take a lot of practice, and if you're doing it online, I'm not sure if there's software out there to help you practice. This is more of an in-class kind of activity. But isometric drawing, some people are really good at it, other people really struggle with it, and all I can say is it takes a lot of practice. So here in example 3, they're asking us to do an isometric drawing of, I don't know why they're calling it a cup structure, but of these blocks here. Let's ignore this. They want us to draw an isometric drawing of these blocks. So again, I find that it's easiest if I can just get one of the sides. So I'm going to work on drawing just this square here. I find that if I can get something concrete to work with, everything else kind of just falls into place. So I'm going to start by drawing a square. If I can get this square right here. All right, so the next thing I want to do is I want to add some depth to it. So from 3 of the corners, I'm going to move back. So back, back, and back. Now I'm going to go ahead and see if I go from the yellow block here to the orange block, it looks like I have to move up and up. So I'm going to go up, up, and over. I can go ahead and draw this line in here. For my blue block, I need to go down and over. So down and over. Go ahead and close this off. Now I'm going to add some depth to both the orange and the blue. So these are going to be like up and over. And that'll give me, it's going to start resembling this block tower. And then the last step is to kind of just do that step that we were talking about before, where we're just connecting our dead ends here. So hopefully that's a good explanation on how to do these isometric drawings. They definitely take a lot of patience, especially if you start using like rounded objects rather than just squares or cubes. But again, working online, chances are you're really not going to be asked many of these. And we're going to take a look at like our next type of drawing. So our next type of drawing, and the last type that we're going to talk about today, is called an orthographic drawing. So an orthographic drawing is another way of representing a three-dimensional figure. And what we do is we show 3 views. We will usually show the top view, the front view, and the right view. And something that we have to be mindful of is sometimes an object will block another part of it. So for example, if we're taking a look at this one, I'm going to highlight this the front view in red. So this is my front view. I could also see this square over here. But if you think about it, the front tower, if you will, this tower here, blocks part of this structure from behind. And that's why in the front drawing, they're showing a little dashed line to show that there is something behind this tower. For the top view, let's highlight it in blue. It looks like we have a square there and this like little L shape. So you take a look, it's an L with a little block beneath it. And then the right view, let's highlight that in purple. So I've got this tower, I have a block and another block. That's why they're getting tower, block, block. So the idea is that if I can see the top, the front, and the right, then I should have an idea of what the three-dimensional object looks like. So keep in mind that we're taking a look at for dashed lines for hidden edges, and the solid lines are the edges that we can see. In example 4, they want us to draw the orthographic drawing for this isometric drawing. So that means I need to draw the front, I need to draw the right, and I need to draw the top. So I'm going to take my three-dimensional figure and I'm just going to color in the front. I'm going to do that with this dark red here. So I have a little block. And then I go almost 2 units up, go over, 1 unit down, 2 units over, 2 units down. So something like this, that's what my front is looking like. If I highlight the right, I'm going to do that in the green. I have a block, I have a rectangle, and another block. So the right's looking something like this. And I've got a block on top. And then the last view that I want to look at is the top. I'll do the top in blue. A block, and a rectangle. So it's a block, and a rectangle. So hopefully between these 3 views, we should take 3 two-dimensional objects and be able to create a 3-dimensional object. So here's a quick recap of the different types of drawings we have. We have the net. The net is a 2-dimensional diagram that could fold into a 3-dimensional figure. So kind of imagine deconstructing a cardboard box. We could always fold it together again to create the 3-dimensional object. An isometric drawing. An isometric drawing is a corner view of a 3-dimensional figure. And then the one we just talked about, the orthographic drawing, that is where we take the front view, the top view, and the right view of a 3-dimensional figure and just draw them as 3 separate 2-dimensional figures. So you'll usually see isometric and orthographic drawings kind of grouped together. All right, so for the lesson check, we just have a couple examples we're going to run through. So for number 1, they're asking what is the net for this figure? So this figure is a rectangular prism. So I'm going to get a whole bunch of rectangles, and they say that it is 5 units long, 2 units tall, and 1 unit wide. So let's go ahead and draw the base here. The base is going to be 5 by 1. And then if I were to draw the sides, they should be 5 by 2, just a little bit longer. And this is not drawn to scale, so 5 by 2s. And then the top should mirror the bottom. It's going to be a 5 by 1. So if I were to fold all of these, I should get a tube, which means I need to account for the right end and the left end. And these are going to be 1 by 2 rectangles. Here's a 1 by 2, and I could draw it over here also, a 1 by 2. Now if I fold all of these along their edges, I should get my 3-dimensional object. For the second example, they want us to do an isometric drawing of this cube structure. So again, I always find that it's helpful if I can draw the first square, I can usually draw the rest of it. So I'm going to start right here. I'm going to draw a square. Let's see, here is my square. Now I'm going to add some depth to it. So going back 1 diagonal, and I'll go ahead and finish off my cube. So from here, I'm going to go up 2. So 1, 2, 1, 2. And I'm going to close that off. I know from this point here, I also need to go back 1, close that off. And now I need to get some more I need to expand outwards a little bit. So I'm going to do some of these downwards to the right. So that's 1 and 2. 1 and 2. Give them a little bit of depth. And now I need to draw this orange one. So orange is going to be up and over, over. And that should be, let's see, I need to finish off this bottom blue cube. That should be my three-dimensional blue, or my three-dimensional cube structure. Double check, make sure I really got all the lines. I believe I did. So that would be it. Number 3, they're asking what is the orthographic drawing of the figure at the right? And they say assume that there are no hidden cubes. So again, this means that they want a front, right, and top view. And they're saying there's nothing hidden here. So for my front view, I've got a square, a square, and a square. So it looks like 3 squares next to each other with one on top in the middle. So it should look something like this. From the right, it's going to look the same. We have a square, and a square, and then one in the middle. So the right view looks basically the same. And then the top view, on the top, it looks like we have a cross almost. So it's going to be something along the lines of this. So that would be our front, right, and top views, because there are no hidden blocks here. And here's the last slide. They're asking whether a drawing is isometric, orthographic, a net, or none. So number 1, there are no dimensions, but this is a net. If we were to fold it together, we should get a pyramid. For B, they give us a top, front, and right view, so that's an orthographic. C, well, this is going to be an isometric drawing. And then for D, I would say this is an isometric view. It's not a drawing, but it is, I mean, maybe if someone was good at drawing, they could draw something like this. It is a corner view of a three-dimensional object. So I'm not sure if the book wanted this to be none, but I would argue that it is an isometric view. It's maybe not a drawing, but I'm going to go with isometric. I wouldn't count you wrong if you said it was none. But other than that, this is the first section of what I call like real geometry. Chapter 13 was all about probabilities. But now we're really going to be talking about shapes and the things that people traditionally associate with geometry. So if anything's not making sense, I would suggest rewatching the video, shoot me an email, I'll try to help you out. And until next time, we're going to take a look at points, lines, and planes. The homework should be already posted, so go ahead and take a look at that, and I'll see you guys in class.